Okay, step question 2012, step 1, question 1. So, quite a simple question actually, and in step papers normally question 1s are quite approachable, yeah? So you should always choose question 1s in my opinion. So, the line now has the equation y equals to c minus mx, m greater than 0, c greater than 0, pass through the point R, A, B, cuts the axes at P and Q. So find P and Q in terms of A, B, and M. Okay, that's more than manageable, right? Just draw the diagram properly, then you will be fine. So, pass through, okay, so R maybe is here, I suppose. P naught is probably here, and then 0Q. So, well, just sub into the equation really, like y equals to c minus mx, so you know that, what is it? So c equals to q essentially, and well, I know that p, well, okay, mp minus, okay, let's do the whole thing. So c minus mp equals to 0, so p equals to c over m, just to make sure I don't make a mistake somewhere, which is equal to q over m, right? And well, I know it passes through AB, so I also know that what is it? B equals to C minus MA, and C is Q, so I have what is this? My B is, well, B is B, sorry. So there's Q minus M times, what is my A these days? So okay, I want to find I want to find P and Q in terms of A, B, and M. Okay, so I already have Q, right? Okay, this already gives me my Q. Okay, my brain isn't quite working today. So this is MA plus B. Well, that implies that P has to be MA plus B over M, right? Okay, there are lots of letters getting around my head. Okay, so as L varies with R remaining fixed, show that the minimum value of the sum of the distances of P and Q from origin is root A plus root B all squared. Okay, well, sum of distances, well, essentially it's just this bit and this bit, right? So essentially I want the minimum of P plus Q. That's my aim, essentially, right? Okay, well, let's do that. So, well, what is P? I know that P is MA plus B over M. And what is Q? Q is MA plus B. Okay, so you see that this is a function of M, essentially. That's the main point you have to spot. It's a function of M, right? Because as L varies implies that M can change or C can change. Both can change, yeah? But this is just a function in terms of M, right? It's just a function in terms of M. Good. How do I find a minimum? Differentiate and put it to 0, right? Differentiate and put it to 0. Okay. So, how do I do this properly? Let's see. So, differentiate this in terms of M, remember, and put it to 0. So, well, this bit is easy to differentiate. That differentiates to A. Now, the first bit, though, so the first bit here, the A is constant. B over M differentiates to minus B over M squared, I suppose. Yeah, hopefully mathematics is correct. Plus A. Okay, and let's put that to 0. That implies that what? Implies that B over M squared equals to A, which implies that M squared equals to B over A. Okay, and we know that M equals to well, plus or minus B over A, I suppose. Plus or minus B over A. Okay, right. Now, does the question have any restriction for A and B? Okay, A, B positive, right? A, B positive, and M also is positive, right? So A, B positive, M positive, so M has to be positive B over A. Okay, M has to be positive B over A. Okay, now I know the value of M, I just put it back in, right? Well, square root of that, sorry. Okay, so I put it back into the expression. So let me erase this. So I put the M back in. So this becomes, so what's the first bit? First bit is A plus B over square root B over A plus square root B over A times A plus B. What is that? That's just A plus, both of them are root ABs, yeah, plus B, and that gives the desired result, root A plus root B all squared. Agreed? Yeah, because I have A to 1/2 is just square root, right? So square root of A plus square root of B all squared. Lovely. Okay, and find in a similar form of the minimum distance between P and Q. So what's the distance between P and Q? Well, you do Pythagoras, right? You do P squared plus Q squared. So this time round, let me give myself some space. So this time round, I want P squared plus Q squared. Right, P squared plus Q squared. That's what I want, right? Or I suppose I want this, right? Okay. And as I said in the videos in one of my, one of the videos in my channels, if you want to minimize something with a square root, just minimize the inside, right? Minimize the inside. So I want to minimize this essentially, right? Don't try to differentiate with the square root. Okay. Let me emphasize. Okay, and P squared over P squared plus Q squared. What is P squared plus Q squared? So I have MA plus B over M squared plus MA plus B squared. Okay, now you just have to differentiate. You just have to differentiate properly. Okay, expand and differentiate. So this becomes A squared plus 2AB over M, is it? Yes. Plus B squared over M squared plus M squared A squared plus 2ABM plus B squared. Okay, now differentiate, The good thing is that some of them are constants, which makes it much more pleasant. So I have minus 2AB over M squared minus 2B squared over M cubed plus, that's annoying, 2A squared M squared plus 2AB. Yeah. Okay, the M doesn't have a square there. Okay, good, and we put that to 0. Okay, we put that to 0. Fine. Now, we just have to solve the equation really. So multiply the whole thing by M cubed, I suppose, yeah? So this becomes, okay, I'll write it in descending powers of M, right? So 2A squared M to the 4 plus 2AB M cubed. I've got minus 2AB M, I've also got minus 2B squared. Okay, right, that is a slightly unpleasant, I suppose. Okay, let's factorize each of them. So this is 2M, okay, 2AM cubed, AM minus B. Okay, yeah, that factorizes nicely. Good. Okay, this is a good factorization technique, right? Do it 2 by 2. Whenever you have 4 terms, always think if you can do it by, like 2 by 2. Yeah, is a good thing to do. I suppose that should be a plus. Good. Minus 2b this time. Minus 2b, am plus b. Lovely. Okay, and am plus b is common, so am plus b. Now what? So, and then this should be, take the 2 in front. So am cubed minus b. Okay, fine. So now I have m equals to minus b over a, or m cubed equals to b over a, which implies that m is cube roots of b over a. Okay, as I said, b is positive, a is positive, and m is also positive, so this is impossible. Literally impossible, right? So the only solution we have to take care of is this one. Yeah, and the question says we could assume that that's a minimum, so we don't have to check, second derivative or whatever. We don't. Okay, now we put it back into the expression. So what was the distance we had? The distance was square root of p squared plus q squared, right? That was, what was my p? ma plus b, all over m squared plus ma plus b squared. Okay. Just put in the m with care, then you will be fine. You will get there, okay? So, step by step, slowly. So this should be a plus, let's use powers, right? Because it would get messy if I don't use powers. A to 1/3, b to the 2/3 squared plus a to the 2/3, b to the 1/3 plus b squared. Okay, should be fine. Steady. So this is a squared plus 2a 4 on 3. B 2/3. This is actually painful. Is there a better way of doing it? No. Plus a 2/3 b to the 4/3 plus, okay, same thing, a to the 4/3 b to the 2/3 plus 2a 2/3 b to the 4/3 plus b squared. Okay, so perhaps we could simplify things a bit. So I have a squared plus okay, so I have 3 a to the 4/3 b to the 2/3 plus 3 lots of a 2/3 b 4/3 plus b squared. Aha, yes, this factorized properly by the binomial theorem. What is it? B to the 2/3 cubed. Lovely, brilliant expression. Yeah, so by binomial theorem, you know this is 1, 3, 3, 1, all right? You can spot the coefficients and you realize that it should be a to the 2/3 and then b to the 2/3 just by looking at, you know, these ones, right? You realize. Good. Okay, lovely question. Just remember, don't differentiate with the square root, then you'll be fine. Okay, and take care of the letters, take care of algebra, don't mess up the positives and negatives, then the question should be safe.